Hi friends, Mrs. Mel here. How are you? It's Tuesday after Super Bowl Sunday. Birds won. And I have a sick little one at home. So I'm sorry I came in early to do this awesome video for you. I'm sure you're prepared to be wowed. Here we go. So ratio and proportions. Yesterday I had you copy the rules from the backboard. What is a ratio? Basically a fraction. Comparison of two numbers. You can simplify it like so. So what you do is, if we want to know the length of AB over BC, I would look at the picture and take AB as 6, put it over BC as 10, and then always reduce, okay? So and it is only 6 o'clock in the morning, so I'm sorry, always reduce. So 6/10 reduces, cut each in half, 3/5. 3 out of 5. AB over AC. AB is worth 10 in the 6 in the picture. AC I would add together and get 16. So 6 over 16 reduces to 3 over 8. Now, this isn't a fraction, but it's still a ratio because we're comparing numbers or items or things. And the colon can also be used in a ratio. This is called an extended ratio because I am no longer just comparing two things. I now have three things, okay? So AB is worth 6, and we write it in the fashion in which it's given, meaning the colons. 6, BC is 10, and AC is 16. To reduce these three, you need to pick a number that goes into all three. 2 is that number. Reduced by 2, we get 3 to 5 to 8. This is simplified. I cannot reduce all three at the same time. Bam, done. This polygonzoid is an isosceles trapezoid. By isosceles, we know the two sides are equal. The lower base angles here are equal. The upper base angles are equal, and the lower base angles are equal. So I'm going to go ahead and label my picture a little bit. Okay. The length of OI is 14, and it is over ZD. Well, first let's find N. We know these are equal, so we would set 7N equal to 14. Because it's isosceles, the legs are congruent. Divide by 7, N is 2. N is 2, I know this side is 14. So now when I go to compare them, it's 14 over 14, which reduces to 1 over 1. This is a 1-to-1 ratio. When things are congruent, we can automatically say it's a 1-to-1 ratio. If I wanted to compare angle D to angle I, the ratio of these angles would be 1-to-1 because 60 to 60 reduces to 1-to-1. Now let's compare the smallest angle, which is 60 degrees, move it over, to the largest angle, that is 120. I notice 60 is half of 120, so this is a 1-to-2 ratio. Let's go to the third example. We're talking about polygon ABCD. It's a parallelogram. That means opposite sides are equal. Top and bottom are equal. Left and right are equal. Let's compare. AB is 10. Compared to BC, that is 6. I need to simplify that. I will reduce each by 2. So it's 5 to 3. Sorry. BC to AD, BC is 6, AD is 6. Woohoo, they're equal, so here we go with our 1-to-1 ratio. Angle A to C, These angles, how many measures? But what do you know? You know that opposite angles are equal in a parallelogram, so what is my ratio? 1-to-1. Correct. Yippee! Flip it. Now, how do I tell if a certain proportion is a true proportion? Does the means extremes property work? Well, what is means extremes property? The means extremes property is basically your cross multiplying, okay? So means extremes is a cross multiplying. If you look on your index card, it says that. So I would multiply these two. 3 times 8 is 24, and 4 times 6 is 24. Is this a proportion? Yes, it's a proportion because 24 equals 24. Let's look at the second one. 5 times 3 is 15, and 2 times 10 is 20. Are these equal? No, it is not a proportion. So it's a true proportion if when you apply the means extremes property, which is cross multiplying, they are equal. Now, rearranging proportions is a little different. Does the means extremes property work? So what they do is they give you a model to follow. Here it is. This model, if when I cross multiply everything after it and it comes back to this model, it is a proportion, okay? That is true to this model. So let's cross multiply this model. I would get x times b equals y times a. So I need to get this in some fashion when I multiply these. Here we go. Cross multiply here, I get y times a equals b times x. Is that the same? bx equals ya. Yes, we're multiplying even though it's xb and it's bx here, they're still equal because you're multiplying. So yes, this is a proportion, yay. How about the second one? X times b equals a times y. Is it? X times b equals a times, yeah. It's a true proportion. How about 3? X times a equals b times y. X times, no, it needs to be x times b. So this is a no-no. This is not a proportion that matches the one I was given, okay? The third one, you're going to need to cross multiply and distribute. It's b times x plus y equals y times a plus b. So I distribute my b times x plus b times y. Distribute your y times a plus y times b. What is the same on either side? This one. So you would subtract it and it would end up canceling out and you'll be left with bx equals y times a. Is that from my original model? Let's go over. B times x equals y times a. Yes, it is. This is a proportion. So now I want to take the time to go back and look at the patterns. Okay? X over y equals a over b. All they did was flip it here. They flipped y over x equals b over a. So I can flip the proportion and it will be true. X over y equals a over b is the model. Go back. They put x over a. They did it across the top. X over a and y over b. Y over b across. Did it work? It did. How about that? Let's look at the one that doesn't work. X over b. What do? They go across, crisscross, okay? You can't do that. You can't go x over b crisscross. That's not going to work, obviously. So no crisscross. And these are definitely some geometry terms, crisscross. Ugh. All right, so let's look at this last one because this is the tricky one. X plus y over y, a plus b over b. They did top plus bottom over bottom, top plus bottom over bottom, and it worked. So I can do top plus bottom over bottom, and it's going to work. Sure, you're super impressed. Here we go to solving proportions. You use the means extremes property, okay? The means extremes property is doing what? Cross multiplying. You can look at your index card as a guide. So here we go. 5 parentheses x minus 3 equals 14x. And now you're going to solve. Distribute the 5. 5x minus 15 equals 14x. Subtract 5x from each side. Oh God, too early. 9x. Negative 15, okay, divide by 9. Ugh. So it's negative 15 over 9, but that simplifies by 3 to negative 5/3. Yippee, our favorite fractions. Oh. Sorry about that. Let me fix I have my phone rubber band to my overhead. All right, here we go. Cross multiply. 4 times x minus 2 equals 2 times x plus 6. Cross multiplying. Distribute 4x minus 8. Distribute 2x plus 12. Subtract 2x from each side. Left with 2x minus 8 equals 12. Add 8 to each side. 2x is 20. X is 10. Okay, flip, almost done. Word problems. Now, if you look on your index card, I have word problems. How do you solve them when they have a ratio? We're going to add an x and set up an equation. How do I do it with a proportion? You match units. So let's see what this first word problem brings us. This is a proportion word problem. If a recipe for 4 loaves of bread uses 3 tablespoons of honey, how much will they need for 6 loaves? Well, what am I going to compare? I'm going to compare the loaves of bread over the honey, right? So in the first recipe, I have 4 loaves of bread to 3 tablespoons of honey. In the second recipe, I have 6 loaves of bread to how much honey will I need? So the top are loaves of bread, the bottom are honey. There's your proportion. Cross multiply and solve. You get 18 over 4, which is 9 over 2, which is 4.5 tablespoons of honey. How can you check? Ooh, ooh, ooh. You're not going to be able to see these. Awesome. You can check by plugging it back in to your proportion. It'll go up like this. Sorry. Okay, here we go. The ratio of the measures of the angles in a triangle is 3 to 4 to 5. Find the measure of each. This looks like an extended ratio, okay? Look at your index card. When it says ratio, you add an x on. So the first triangle becomes a 3x. The angle. The second angle becomes a 4x, and the third a 5x. So if I drew a picture, it would look like this, the angles in the triangle. Now, how do I find the measure of each angle? You make an equation. These 3 will add to make 180. 3x plus 4x plus 5x equals 180. Add your x's. 12x is 180. Divide by 12. You get x to be 15. You're not finished. You need to find the measure of each angle, so you plug x back in. 3 times 15, 4 times 15, and 5 times 15. I get 45 degrees, 60 degrees, and 75 degrees. And these will add up to make 0, 1, 10, 11, 8, 180. Sweet. Okay, so the ratio problems, you make an equation by adding an x. The proportion problems, you set up 2 fractions equal. Number 3, to complementary angles. Complementary means add to make what? 90. Are in the ratio of 1 to 2. Find the measure of the two angles. So that means I make this a 1x and this a 2x because it's a ratio problem. Okay, complementary means they make 90, so I'm going to add them to equal 90. 2x and x together is 3x equals 90. Divide, x is 30. You're not finished. You need the measure of both angles. So what I'm going to do is I'm going to plug it in. The first one's x, so it's just 30 degrees. The second one is 2 times 30, which is 60 degrees. And do they make 90? They do. Sweet. Okay. The fourth one, in a rectangle, the ratio of the length to width is 3 to 2. Ratio. The perimeter, all of it added together, is 60 feet. Find the dimensions. So I'm going to sketch this. I have a rectangle. Length to width is 3 to 2. So you make one side 3x, the other side 2x. So my length is 3x, my width is 2x. Perimeter is 60. That means all sides added together. Well, I don't have these two sides, or do I? It's a rectangle, so the opposite sides are equal. Now you're going to add up the exterior to equal the perimeter of 60. So 3x plus 2x plus 3x plus 2x equals 60. That gives me 10x together equals 60. X is 6. Plug it back in to find each side. 3 times 6 is 18, and 2 times 6 is 12. So I have 18 feet by 12 feet. Those are my dimensions. Whoops. Good? Good. Now, good job. You need to do the rest of this packet, okay? I wish you luck. Whoever is in here has the answer key if you want to come up and check as you go along. And if you look on the side board, you'll see we're doing proportion and similarity today. You may have a mini quiz on this tomorrow. We're going to do similar polygons tomorrow. And then Thursday is parade day. Thursday is parade day. And I won't be here. And I hope that you will have a great day that day too. All right. Peace out. See you Wednesday.